explain the information related to the participation in the open call of the Intefix project, and I will give some information about the project and how to participate and some key points to be able to make the proposal in the right way. So, more or less, I will make some slides with general information of the project. After that, I will explain some specific information of the open call and how to fit these participants in the open call in the project. And also I include a description of the current application. I will try to be fast in these explanations. And finally, I will make some remarks for the open call applicants. These remarks are related to the question that I have been receiving during the last days, and just to clarify some concepts and to be able to explain who is included in the open call and what applications cannot be included. So regarding the general information about the project, as you can see, this project has started in July of 2013 and will last 3 years. And here you can see the budget and the EC contribution. And from this EC contribution, the reserved amount for the open call is this one. So we expect a minimum of 3 new experiments in this open call. And here you can see the different partners, and well, each one has a different role within the project. This is important because you can see here the countries that are already participating in the project, and to be a company outside of these countries is an important added value for the project. So, well, regarding the objective of the project, this project is related to manufacturing processes, and more precisely to machining of medium and big size components. And well, the objective in this case is to increase the performance of the processes, and in this way, different systems affect the performance and the results of the project. Well, 3 of these issues that affect the processes are the machine, the fixture, and the process itself. Well, the project is focused on the fixture side, but obviously there are some interference on and interactions with the process and machine. But basically, the developments has to be focused on the fixture. And regarding the fixture, the conventional function of one fixture is to hold and locate the workpiece within the machine volume. And all of these elements affect the precision, quality, and cost. So the fixture also affects this. And the objective is to improve the behavior of this element to increase the aspects associated to these items. Okay, so here I will try to explain how we have make the planification of the improvement of the fixture. So the idea is to develop intelligent fixtures, where normally the current used fixtures in the industry are mechanical elements or maybe hydraulic actuated, but mainly they use mechanical concepts, and they have the design and a working way. So the idea here is to include sensors, actuators, and control algorithms in order to be able to obtain an intelligent picture that can adapt its behavior to the process and machine issues during the machining process. So basically, we use the sensors to monitor the process through different control algorithms and software and hardware. We make the target behavior, and through the actuators, we change the configuration or the behavior of the fixture to be able to increase the quality, precision, performance, efficiency, or sustainability of the process. So here there are some key concepts on the project, and well, the first one is to include the mechatronic or electronic systems in order to match this intelligent work in the project. And the second one is the adaptability. Well, the incorporation of actuators in the fixture is for the adaptability of the fixture itself. So we have a tunable behavior, or we can change the behavior of the fixtures, basically moving the actuators and changing the characteristics of the fixtures. Third one is the modularity. When we use advanced fixtures and fixture elements, we use this kind of sensors and actuators that are expensive elements. So in order to be able to reuse and to expand the applications of the elements, it's a good idea to build this in a modular way in order to be able to apply to different fixtures, applications, and to reduce the investment cost in this kind of actuators, or well, in this kind of fixture elements. And finally, a future idea is to have flexibility in this kind of intelligent fixtures. So the concepts that are going to be developed in the project can be useful for other applications like welding, assembly, or whatever you can imagine. So this kind of elements and target objective of these elements could be also applicable to other processes, not in this project, but could be. So the flexibility could come from this application to other processes. Well, regarding the problems covered by Intefix project, as I said before, it is related in machining processes, and three common problems in machining processes are the vibrations, the deformations of the workpiece during the process or previously due to the clamping forces, and also the positioning of the workpiece within the machine volume or within the fixture itself. So, well, in this case, vibrations can come from the workpiece or itself, or maybe from the workpiece process interaction. The deformations mainly come from the clamping forces or the residual stresses and problems that arise when the material removal is advanced and these residual stresses change the internal state of the workpiece, and then deformations arise. And finally, when the workpiece is picking up, the positioning of the workpiece in the machine is not easy in some occasions and sometimes. So it's useful to have the possibility to move the workpiece or to change the references of the machine. So key concepts here are machining processes and problems related to vibration, deformation, and position. Well, this is the main objective of the project, and well, up to now I have been talking about the development of the fixtures and fixture elements and the objective of these fixtures. But well, in fact, the objective of the project is to make this development or the integration of state-of-the-art systems, mainly related to sensors, actuators, or software, hardware, or whatever you can imagine, and to integrate these systems to make the fixture. I mean, that's to use state-of-the-art systems in fixture applications, taking into account that the use of these systems is not usually used in the fixture field. So one key point is the integration of state-of-the-art systems. And related to this, the main objective of the project is to develop a methodology. That is, how can we use these systems in the development of the pictures and be able to use these systems in machining processes and to obtain an advantage in that machining process. So that's why we want to develop a methodology and not only the experiments. The idea is to use these experiments as validation proofs, but after that we have to define the methodology to be able to apply the same concepts to other applications or in other machining field applications or in other processes. Another point is the adaptive fixture. So we have to develop the intelligent fixtures, and this has to work in a fast and accurate way. So we can include many systems, advanced systems, like sensors, actuators, etc. But if we cannot make a fast and accurate working way for the fixture, we are not making anything useful for the industry. So that's why we have to be care of these aspects. And finally, the modular elements are something that I have commented before. That is, we try to make modular elements in order to get an easy configurability of the new fixtures, and also be able to reuse the expensive elements like sensors and actuators in new fixtures or on new applications, machining or other processes. Okay, so I will start here with the project structure. This is related to how the project is arranged right now, and this is arranged in experiments or case studies. So we have the three problems related to machining, and each problem defines an scenario. Okay. At this moment, the project has two experiments in the scenario 1 of vibrations, 4 experiments in the scenario 2 deformations, and 2 experiments in positioning scenario. So these experiments last 18 months. And well, there are different profiles of companies, but mainly it's experiments as a mini consortium that is formed by a coordination partner, and this can include, well, this should include an end user. This end user will make the validation and the definition of the requirements. I mean, what kind of work is, which is the problematic process, which is the problem, the specific problem, and what kind of pictures are they using right now. And so with this information, the coordinating partner with in collaboration with technology suppliers and marketing performers should make a proposal for an intelligent picture able to solve the problems specified by the end user. So that's it. That's why we can see here in the table partners providing sensors, actuators, software, and algorithms for process modeling or whatever. Also monitoring and control partners, partners that are supplying advanced fixtures or conventional fixtures that can be modified, and also machining technologies. This side is mainly based on the end user side, but could be different from the end user. So here the important things are the structure of the experiment or case study that should be formed by an end user and at least one technology supplier. And well, the experiment should last 18 months. Regarding the management structure of the project, this structure is already established. So the incorporation of the new case studies should fit in this management structure. Up to now, we have 4 different committees. The steering committee is more related with the general management of the project, and we solve common day problems due to the communication with the different experiments and with problems related to general justifications and general activity of the project. The exploitation, IPR, and dissemination committee deals with how the results are going to be exploited and protected, and also the dissemination of the results of the project. That is an important issue for the EC. Well, the technical committee is formed by the work package leader. So the leader of the selected case studies in the open call will be integrated in this technical committee, while the rest of the participants in the selected case studies of the open call will be integrated in the General Assembly, where the common issues of and the advance of the project are presented for the whole consortium. So basically, in this slide, you should take that that you have to be integrated in this structure and the current process, and you are not if your case study is selected, you are not as a standalone project. You have to be collaborating with the remaining partners of the project, and you mainly be involved in this area, in the technical committee and in the General Assembly. Okay. Well, now I'm going to say what we expect for the people applying for the open call. So I have set 3 steps. First of all, you have to define the problem, the machining problem, and an application, and this should be classified in one of the 3 scenarios. After that, you should form a mini consortium with the required profiles for the different companies, and with these companies you should form the consortium of the project, and after this make the distribution of the work and the planification of the work, and submit the proposal to the portal. Well, as you probably know, the deadline is April 2, and we expect to have the evaluation results by May 29. And basically, the idea is to start the new experiments within the project in July 1. So, as we expect at least 3 new case studies, and the original easy contribution reserve for this is 1.45 million euros. So if we have only three case studies, each one will have up to 485,000 euros. If the selected proposals are below this quantity, maybe we can select more than 3. If not, we will select only 3. So this is a maximum easy contribution that you can reflect in the proposal, but it could be lower. Well, the selected case studies will start their contribution in the second year of the project, that is the July 1st of this year, 2014, and the experiment will last 18 months until the half of the third year of the project. And well, in this area, the last 6 months of the project, there are some contributions of the different case studies or experiments, and in this case it's related to the development of the methodology. That is the main objective of the project that I commented before, and also obviously the different partners of the project will try to disseminate or exploit the results. So this is a common contribution to any European project. So this is common, and I think that you should know how this works. And this is only the real special issue, this methodology development. In this case, what we expect is to be able to make a structured knowledge of how the intelligent fixture works and how it can be implemented in new applications, in order to be able to transfer this to the industry, and not only to the specific experiments made in the project. So I will start with the second part of the presentation, that is the definition of the current case studies. So here I will try to explain the 8 experiments that are currently in the project, and this is for you to take this into account, and you can make an idea of the different applications and different solutions, because the expected case studies proposed in the open call should complement this, being different from this one, and to make new contributions to the project. So the first one is this case study, and it deals with a vibration problem in the milling of this kind of impellers. And this workpiece is made of aluminium and is manufactured in 5-axis milling. And so the objective is to reduce the vibrations in these plate areas that are slender and low stiffness components. So the idea is to monitor the fixture to be able to detect the vibrations and the unstable cutting conditions that is mainly associated to chatter, and well, try to avoid these vibrations. Here the end user is Eagle, that is also a manufacturer of fixtures, and here you can see different technology suppliers, fixtures, sensors, actuators, and ISF is providing simulation tools, and the University of Magdeburg is the general coordinator of this case study. So here the idea is to integrate sensors and actuators to minimize the vibrations through an intelligent chuck that is working in this area of the workpiece during the machining. So through monitoring the vibrations and introducing the small movements, they will try to reduce the vibrations. So in this way, it's important to develop the correction and control algorithms, and it will be based and aided by the process modeling and dynamic simulation of the process. Well, the second one is also related to vibrations. It's a case made of Incon 718 for aircraft applications. As you can see here, is a big, relatively big component, and also in this case there are problems associated to vibrations due to the low stiffness of the component. As you can see, the thickness of the component is really low related to the other two dimensions of the component. So here the idea is to be able to change the boundary conditions of the component in order to modify the dynamic behavior and dynamic stiffness. So if we change the dynamic stiffness, we change the behavior of the workpiece and their response to the cutting forces. So here the idea is to integrate sensors to monitor the process, and also to integrate actuators. Here by actuators we can understand different options, and we will try options like vibration absorbers, both active and passive vibration absorbers, and also we will try to introduce intelligent fixture elements able to modify the clamping force and the clamping position of the workpiece in order to modify that boundary conditions and to change the dynamic behavior, basically by modifying the stiffness and the damping in different areas of the component. So through this, we will try to minimize the vibrations during the process. In this case, the end user is ITP, that is a company here in Spain dealing with the manufacturing of the low pressure turbine of aircraft engines. Well, this case is the first one of the scenario 2. This is the deformation scenario. And basically it's an aerospace workpiece for the aerospace sector made of aluminium. And here we have the problem that the raw workpiece is a block of material. So here there are a lot of material removal during the process. So the residual stresses become important during the material removal process, and some distortions and deformations of the workpiece become relevant. And so here the idea is to detect the force coming from that distortion. I mean, as we advance in the process and remove material, some distortions are produced in the workpiece, and well, the partners will try to measure the forces, the reaction forces in the fixture, in order to assess the distortions of the workpiece. And as then with that information, they will try to compensate the distortion through movement of the positioning pins, and also by changing the clamping force. Well, this cannot be done all during the whole processes, so they will try to establish different steps during the manufacturing, and make the approach for each manufacturing step. And in this case, it also includes the communication with the CNC of the machine tool in order to modify the tool path for the deformed configuration of the workpiece. So as the process progresses, the workpiece is deformed, and the tool path is adapted to the new deformed configuration. Okay. The next one is quite similar to the previous one. It's also an aeronautic component, but in this case, well, the problems are similar, and the solution is also similar. On one side, the idea is to integrate sensors to measure the clamping forces, but in this case, the control algorithm will be related to the change of the workpiece stiffness. So as the process progresses, the material removal process produce workpiece stiffness change, and the idea is to control this stiffness in order to set the new conditions and the new clamping forces and positions. And also in this case, it's important the integrations of sensors to measure the thickness, the resultant thickness in the workpiece, in the final workpiece, because an excess of thickness means more weight in the aircraft, and a defect of thickness, and a thickness lower than expected, results in lower stiffness of the component, and possibly a fail of the component in use. So that's why they want to check and to measure the thickness during the process to assure that the resultant workpiece is within the tolerances and under the requirements of the end user. So the third one is also an aeronautic component. In this case, with intensive material removal. And here you can see an example. This is not exactly the component that are going to be treated in the project, but it's a good example of what can be obtained if we don't take into account the residual stress in the machine. So here the idea is to control the clamping force and apply controlled displacement during the process. So the objective here is to develop clamping elements that work in this way. First, we we look for contact with the workpiece, and second, we make the clamp without deformation. So the idea is to follow the deformation of the workpiece and try to correct. So we avoid the introduction of additional stresses due to deformations associated to the clamping, and also through a mathematical model of the residual stresses and the deformations occurring in the workpiece for different machining steps. The idea is to predict the state of the component after each machining stage. So in this way, a machining process can be proposed in order to correct and compensate the distortions and the deformations occurring in the workpiece during the process. Well, the last one, the deformation scenario, is this workpiece. It's also an application from ITP, and it's also for an aircraft carrier. Here the problem is that this component is made by welding mainly, and so welding introduces distortions in the component. And this big component is really difficult to fix in the machine, to make the machining operations without I don't know how to say it, meeting the tolerances of the panel workpiece. So the machining areas in this workpiece are these flanges, these external flange, these internal flange, and also this one, and the same in the other side of the component. So as after the machining, the process, the workpiece is deformed by the welding. We have to adapt the fixture to clamp the workpiece without introducing additional deformations. So the idea here is to have clamping elements able to measure the force and the position of the different clamping elements, and try to define the position of the different clamping elements to minimize the distortion introduction by the fixture and the clamping forces. And also, in this case, there is an important problem that is also related to vibration, but this is a secondary problem because of the low stiffness of the different areas of the machining process. And well, in this case, the machining operation is a turning operation, so it's an additional problem with the rotary motion of the workpiece. So the power and the signal transmission for the sensors and actuators should be made in a rotating system. So we have to use slip rings or whatever for the power transmission, or wireless signals for the sensors measurements and so on, and control cycles. Okay, so we start now with the case studies related to the scenario 3. This is positioning issues. Well, this first one is related to the manufacturing of train components. This is the lateral side of a train car, and so as these components are so long and has an important weight, these components get deformed when they are loaded in the machine. So these deformations are not controlled, and the idea is to reduce the setup time. That is, For instance, I want to know how this workpiece is located in the machine, and I know where the component should be. So I try to move the clamps and the position of the different clamping elements in order to move the relevant geometrical issues of the component to the right position. So the idea is to include modular fixture elements for leveling the workpiece and to move the workpiece to the right position in the machine work space. And basically, this will be done with independent movable supports, able to measure the force and the position, and work in a closed loop. So the different elements will be controlled by a single controller. Okay, this is basically the application of this case study. And the last one is also related to the positioning of the workpiece in the machine volume, also with big components. And in this case, the idea is to use a machine integrated vision systems. That is, an scanning of the workpiece will be made, and then this information is translated to the controller in order to move the different clamps and locators to change the position of the workpiece. And also, some of these components are deformated or distorted with the clamping forces. So these clamping elements should take care of these distortions, avoiding the excessive distortion of the workpiece, because this could result in lacks of material for different machining applications. So we have to be sure that the workpiece is correctly located in the working volume of the machine, and that the tool path is fitting the actual position of the workpiece. So after this long and tedious description of the work package and case studies already defined in the project, I will try to make some remarks about the participation in the open call. Okay. So the first one is this one. This is the original call of the project. Yes? This is a project from the FP7, and the project is related to this Challenge 7 of the ICT program, and it's for the enterprise and manufacturing. So, well, the objective of the project is the equipment assessment for sensors applications. Okay. So here, three key concepts should be remarked. One is this kind of this word enterprise. So the idea is to have SMEs with own products, and these SMEs will act as technology suppliers. So the idea is to strengthen the supply side of these SMEs and find new applications for these products. So that's why it's important to have SMEs and acting as technology suppliers in the consortium. Okay, and also the other key word is the manufacturing. So the idea is to develop systems and new products able to improve the manufacturing sector in Europe. The manufacturing is an important sector in Europe because it has and economic impact in the European Union. And so the idea is to develop new products able to be integrated in the manufacturing chain and improve the performance of the machining process in this case and manufacturing process in general. But so that's the relation with the manufacturing. So the idea is to develop advanced systems able to help the manufacturing sector to improve the performance of the manufacturing process and to improve the results.
Ya, ayer hablábamos, por eso íbamos subiendo una. Sí, no te quedas
esto puede ser así. The relation between the manufacturing industry and SMEs is the application. Applications for the products of the SMEs in the manufacturing sector. So you have to take this into account during the establishment of the objectives and the explanation of the objectives of your application or case study. Another question that I have received from different persons is the thematic area of the Intefix project. So now, the project is only related to machining processes, not any other process like welding, assembly, or other processes. At this point, it's only for machining processes. And the focus is in the improvement of the fixture by the integration of sensors, actuators, and control algorithms. So this is to provide the fixture with some kind of intelligence. Okay? So this is another key point that I want to know. Well, regarding the expectations for the new experiments from our side, the current partners of the consortium and the management of the project is to get new experiments related to one of these scenarios, and the idea is to bring to the project new applications and new solutions. Okay, so you have to make clear the difference of what are you proposing and what are already existing in the project. That's why I have made the long explanation of the different case studies. I cannot be more explicit because there are some protected information that I cannot publish now. But you have to take this into account. Your proposal should be different from those already existing in the current problem. Okay, so the idea is to propose complementary experiments with new solutions, basically, in order to enhance the impact of the project. And well, regarding the experiments, this will include all participants, all partners necessary for the development of the experiments. I mean, if you need some kind of sensor or actuators, you should check for the right partners able to supply this kind of systems or integrate this kind of systems. Regarding the evaluation of the proposed experiments, the proposals, I think it's clear in the guidelines, but there are three different criteria. The first one is the scientific and technological quality. The second one is the implementation. This is related to how you are going to work in the case study and how the work is, well, the role of each partner and how are you going to work together. And finally, the impact is how the work developed in these experiments are going to get an impact in the industry and basically in the manufacturing industry and also in the supply side, the SMEs with own products. That is to find new applications of the products of the SMEs. And another key point of the evaluation is that this is carried out by external evaluators. I mean, I'm not going to evaluate the proposals. So it will be some external evaluators that will make an independent evaluation from the partners already involved in the project. And we will try to find at least 2 evaluators with expertise in the field of the proposal. Our idea is to have more than 2 evaluations per proposal, but if we have problems to find the right experts, we will limit this to only 2 evaluations. Okay, regarding the partners and the different components of the mini consortiums for the definition of the proposal or case study. Regarding the different countries, normally in the European projects you have to include 3 different countries and 3 partners from different countries. In this case, there is not any specific requirement about the number of different countries, but more than 1 country and additional countries to those already represented in the consortium is a plus. So the evaluators will take this into account. It's not mandatory, but the evaluators will take this into account. Regarding the number of the partners, it's the same. There is not a specific requirement about the number of partners, but at least it should be 1 end user and 1 technology supplier. And also it could be other profiles like companies dealing with the integration of the different systems in the fixture or for development of the control or whatever. And in this case, it's also the same. At least a reasonable number is 2, an end user and technology supplier. But more than 2 partners is also a plus in the evaluation, because as you can see in the previous slide, it's important to strengthen the supply chain and the supply SMEs with new advanced products. So that's why it's important to have as many partners as possible from this side, this technology supplier side. Regarding the end users, only 1 is necessary. And well, another question that I have received is, well, there are some partners that are already participating in the project, but some of them could participate in new proposals. This is not forbidden. The already existing partners can participate in the new proposals, but the easy contribution is limited to the 25% of the total in the case study. I mean, the contribution requested by the partners already participating in the Intefix project can claim only 25% of this amount, or the total amount in the case study. Well, regarding the integration of the new partners and new proposals in the Intefix projects, well, you have to accept and sign the project consortium agreement. I think a copy of this is uploaded in the Intefix web page, so you can check if you have any conflict with this consortium agreement. So you have to be sure that you are going to meet this consortium agreement. And also, well, this is related to to the methodology development. So with this sentence, I want to stress that that you are not going to work as a standalone mini consortium. You are integrated in a consortium bigger than that mini consortium that you have said, and you have to share experience and collaborate with other case studies to the development of the methodology. So the new case studies are not a standalone project. You are collaborating in a big project, and you should take this into account. And this is basically the contributions expected for basically the dissemination, training, and standardization possible, and basically the new products. This is the exploitation of the results of the project. And for this activity, I have set standard effort for the different partners, and this is 2-person months for the coordinating partners of the case study, and 1-person month for the other participants in that case study. And I think this is the last one. It's important that you have a big code for the participation in the project. So this is a thing that you can do at any time. So you can do it right now, and it's better if you have this pyramid made before presenting the proposal. But you have to. But this is necessary by July 1st if you want to join the project. Probably previous, and also the funding rates are those established in the FP7. So the idea is to set the new experiments as a single work package, and the type of this work package will be research and RTD activity. So the typical funding rates for the different company profiles are this one. The SMEs, RTD performers or universities can claim up to 75% of the budget, and large industry has their claim limited to 50%. So this can help you to make the budget and the requested contribution of the European Community. And well, I think that's all. So now we can answer your questions or whatever you.
Okay. Yes. Is anyone else asking questions, or can I start?
No, you can start. Just one thing, Silvia has lost its connection. But yes, we can go on with the question. You can. Okay. You can talk. Pardon.
Actually, I have several questions, but I'll try to make them short. But I'll take them in reverse from the easiest ones to the hardest ones. Looking at the last slide, I have one fundamental question. Where it's mentioned that the SMEs, RTDs, universities will follow FP7 rates, so that was 75% of the total budget. The thing is that what I don't understand here is that if you're referring to FP7, although you're referring to the rate for the overall, the thing is that this was also associated to an overhead. So my question is the following. In FP7, SMEs, RTDs, and universities had 60% over indirect costs, and then it was applied the 75% of EU contribution to the total budget. But in Horizon, as you know, the overhead has now become standard across the board to 25%. So not talking about the end funding, but the thing is that the percentage that you mentioned corresponds to what overhead? Horizon 2020 or FP7?
It's FP7. I think it's clear from the slide. We have the FP7 roles. FP7 roles.
I see. So it's then the 60% indirect and then 75. Okay, that's clear now. Okay. I just want to clarify that because that's one issue that everyone talks about. It's the indirect rates to be correct from an accounting point of view. Okay, so my second question is the following. This goes now to the technical part. Although I was in the watching the presentation from the beginning, I didn't have audio from the start. So one thing I have probably missed is the following. The proposals to be submitted these correspond to the specific demonstrators in the project? Or when I mean demonstrator, I mean the actual machines that are in the project? Or is it that partners who, let's say, from the consortium composition that you said, that let's say if I have an industrial or an SME partner who has a relevant case to this, we are required to bring in not new, but additional machines to support that case? Or is the project, what is going to be created, going to be applied directly to the machines already in Intefix? I haven't been able to clarify that.
Okay, the idea is to find an end user able to supply the machines and the case study necessary for the development of the experiment. No, the idea is not to use the machines and facilities of the current partners. You have to find an end user for that. I don't know. I'm not hearing any.
Do we have more questions?
Well, Gianni Campatelli speaking from the University of Firenze. I have just a very simple question. Could you have the presentation, also the PDF, it's okay? We want to reduce some data that you presented us, so it will be useful to have the file.
You are asking for the presentation?
Yeah, just the PDF for the presentation, if it's possible.
We can upload the presentation in the website. It's not a problem. I will make it. I don't know, maybe today or tomorrow. I will make that. So
it's okay, thank you.
You can send it to us and we will upload on the E4MS website.
Yeah, also. Yes, sure. Okay. So, any more questions? Hi. Sorry.
No, I just wanted to say that go on. It's your last opportunity to make some question to Oscar regarding Intefix.
Sorry. Yes. So, there is somebody speaking right now? I don't know.
So, no more questions?
Well, I think that now we have to think about the case study. We have already started to work.
Well, the presentation by Oscar was quite detailed and all the most important information, I think, were given. And, well, anyway, you can contact us at the E4MS website for for some doubt that you can have in the next few days. Well, I would like to thank Oscar for this very well prepared presentation, and well, I invite all of you to frequently have a look at the E4MS website to be aware of all the initiative we are going to have inside the initiative. I also remind you the event already mentioned by Silvia at the beginning that we are going to have in Berlin in June. You will receive more information next week about it. Thank you. Oscar, if you would like to say something to close.
Thank you to all of you for organizing that, and the participants and the attendance to the presentation. Thank you.
Yes, sorry, because my audio was muted, can I finish my one question that I had so you can close the WebEx, or do you need to close the WebEx?
Sorry?
I had a question, but my audio was muted for some reason, so I was okay. So do you want to close it now, or can I ask the question?
You can.
No, you can go on. Please.
Okay. So just to close up the previous question I had, of course, as you said, the end user brings his case, which is though relevant to the ones that you showed. They have to comply to the same application. As I understood from the presentation. So the thing is that the reason why I asked about the other machines already in the project is that the solution you make in the small project, is there a requirement that it must be adapted or transferred as a result to the other machines? That's why I was asking whether the projects need to correspond also to the specific machines already in Intefix.
No. You have to set up a new consortium with an end user
and new machine. Okay.
Yeah, your application will be related to that end user and their means.
Okay. Well, I was just asking if there was a requirement that the solutions made also need to be transferable to the other machines already in Intefix as a result transfer.
Yeah.
Okay. All right. So the last question, so we can close, is the following. Because our main interest is in the vibration part, because I heard mentioning of modeling and simulations and such, but also there's mention of about intelligence in the fixtures of the machines. Is it also, I would say, acceptable? I want to say applicable because it is applicable. That per the business case of intelligent systems, that for, let's say, for vibration, is it also possible to propose technologies that are autonomous? Meaning that you do not require models or simulations, because a lot of, you can be a company and have very knowledgeable engineers, but not everyone can be knowledgeable in every facet. So for vibration control, if you do not have specific expertise or you do not have the models or simulations, it's very difficult to implement such a system. But it is possible through, let's say, what they refer to in H2020 by autonomous systems that rely on artificial intelligence to be able to do this. So you can apply control solutions through online learning or by retrofit to the machines. I mean, it does not involve a design stage, because we assume in such cases that there are no models or simulations available to apply such a system. So is that out of scope of Intefix, or is it acceptable to try to propose such?
If I understood your question.
Yes.
You're saying that you want to use an external system, and if it is possible to buy this technology and integrate in the cases.
No, we have this technology. We as a partner have this technology. But the thing is that the reason I'm asking this is because usually for active control systems, 99% of the times, they are multidisciplinary in the sense that you need to create models, you need to create controllers, you need to conduct simulations, and et cetera, et cetera. So the thing is that when you do not have these available, and I'm not talking about Intefix, but as you say, there is an impact issue of how to give this to industry, is that what happens when you do not have models or data or such thing, how can you apply such systems? So in our respect that we deal with such systems, there's also science and technology available to say that, let's say, in Intefix there are sensors and actuators on the machine and fixtures that through the feedback that you get from the sensors, the artificial intelligence technology is able to create vibration control or noise control, whatever, without the use of prior models. You see, it does it online. So that is
you can use.
So it's within scope. It's within scope. That was basically my question, actually.
I think you can use the kind of models you think.
Well, that's the thing. I'm saying that this does not involve.
You have to be sure and demonstrate that they are useful and good enough for the application.
Yes, well, that is not. I'm not trying to ask that here. All I'm saying is that what is within scope. So the thing is that for things that require models and such, we already have these things. That's not a problem for us. But from a business case point of view, there's also the issue that what happens when you do not have models? How can you apply such systems without models? And not so that goes to another realm of technologies for these applications. So I was just asking that, is it because I do not assume that it is everything is within scope of Intefix, that is also artificial intelligence to applicable or within scope to be able to help SMEs who do not have modeling and simulation knowledge to create such systems, to apply such systems through artificial intelligence.
I'm not sure if I understand well, but I think.
I think from what you told me, it's within scope. So I don't think.
If you are able to apply this to the picture, for sure, it's within the scope of the.
Okay, that's all I wanted to. That's all I wanted to know, because that's really on the impact side of the proposal. So we wanted to be sure not to propose too many things in the project, but to know where the limits are. So since this is in scope as well, then it's not a problem. That's basically my question. Thank you.
Well, Harry, if I could offer my contribution, I think that you are right. Also, we are working on the black box approach. I think for the application on a small and medium enterprise, you don't need the simulation. Also, simulation is dangerous because you need the competency and so on. I fully agree that for the implementation on SME production company, your solution is the best one.
Sorry, I cannot hear you right.
Well, it was just a brief feedback on the introduction to the black box technology of Harry, but well, nothing really important.
Hello, can you hear me? I didn't hear what you said previously. Could you repeat that?
Yeah, sure. It was just a comment to your introduction.
Yes.
I think that for the introduction in small and medium enterprise, the solution that avoids simulation is the only one feasible. Because if you need simulation capability in a small and medium enterprise, probably you don't have small and medium enterprise.
But it's
we believe that black box approach is the best solution. During the presentation, I see simulation, dynamic simulation of impeller, and I think it's a little bit dangerous for me. So
no, it's yeah. So we agree on that. And it's also the fact that even if you have the experts in the SMEs to create these models and do simulations, it comes at a very high overhead also. So it's not only the experts. So just want to close the question because of what you mentioned. One thing I'm not sure is that is Intefix only focused on the application to the fixture, or actually also providing the means for manufacturers of the fixtures to make these through production lines?
Well,
because it's not only the application, but then the machine builders. Is it also in scope that machine builders should have techniques to be able to enhance their products during the production phase, to have this integrated into the production of the actual fixture?
Yeah. Well, the objective of the project is not to develop ready to market products. So
no, I'm not saying that. But the thing is that there's a solution made for the fixture. Okay, so that is clear. That's not an issue here. But the thing is that the issue that the solution for the fixture is for the person who's manufacturing the product. Okay, so that's one side of the equation. The thing is that before the person who is manufacturing something is using Intefix solutions, he's using it on a machine that he has purchased from a machine builder, or a machine manufacturer. So I'm saying that are Intefix solutions here for the proposal just applicable to the end users who will use Intefix to produce another product, or is it also applicable that another case study is for the actual person who is building the machine to have the means to integrate Intefix in his production of the machine?
So you mean a machine tool builder that is providing a turnkey solution?
Mm-hmm. Yeah. So is that in Intefix or no?
In this case, the machine tool builder is a technology supplier, so it's not an end user.
Okay. That's clear. Okay, thank you for that answer. Okay. So I have no more questions. Thank you for that.